Hi, I'm Connor from Connor.engineer, and today I'm going to be going through how I designed and 3D printed this hinge mechanism in SolidWorks. So you can see it's very similar to a door hinge, common door hinge that you would see, except it's a lot smaller, and the hinge mechanism moves quite freely. So yeah, I'm going to go through how to draw this in SolidWorks and how I worked out the different tolerances and stuff. You can see there's no play in it or anything. The tolerances are worked out correctly. I had to do a few different prints to work out the tolerances for this. If you saw my previous thread drawing video, you'll see how I figured out the tolerances for that. The tolerances for this are different because this is a print in place model. So this prints as one piece and you can't take it apart. But it's still able to move because there's gaps within the part, but it can't be taken apart. So we'll go over to SolidWorks now. Okay, so I've just created a new part here in SolidWorks, and I'm going to start a sketch on the top plane. So I'm going to draw a rectangle to start the basic shape of the hinge, and I wanted to mention that to be 50 by 25. These dimensions don't really correlate to anything. It's just a small print, just so it's quick to print, because I had to print a lot of different ones of these to get the print working. So we're just going to extrude that up 4mm as well. This isn't really important either, it's just to give a quick print and it kind of gives a solid test piece. So that's our main rectangle. So we're going to come parallel and look at this edge, and now I'm going to sketch on the end of this, and I'm going to draw a circle whose radius is the same as the height of this piece. So that circle is fully defined because its radius is along this line, and we're going to extrude this the whole way through the piece. That's going the wrong direction, so we're just going to go through all the way to the other end, and you can see that we now are starting to get the basic shape of our hinge here. So the next thing I'm going to do is I'm just going to put in some fillets, just because it's convenient to do this. I'm using 2mm fillets here, just because it'll give us a nice rounded edge on this piece, because it's 4mm wide, so you can get two 2mm fillets on a 4mm wide piece, high piece. So that's starting to come together there now. I'm just going to draw some holes. These aren't really that important, it just kind of makes it look more like that classic door hinge shape that you would see. So I want this to be along this construction line is just to help me line up the circles. I want it to be in the middle of this piece here. We have those two circles. I'm going to pick 4mm here. Again, it's not really that important. These are more cosmetic than anything else. And because the piece is 50mm high, I'm just roughly dividing it into thirds here. So I know 3/15 is 45, but it kind of roughly gives you the right amount. You could work it out properly. But again, these cuts are not functional; they're just cosmetic. So we're going to cut these through all, and next I'm going to put a chamfer on it. Again, this is just to make it look more like a door hinge. This is not a functional part of the piece. So we're going to put a 2mm 45-degree chamfer on both of these, and now we're just going to do some more filleting. Just because I don't like to have sharp corners in my designs. When you're working out fillets, just try and get the sizes to where it looks good. Like these are 2mm fillets, I could easily use a different size, it's just I think it looks nice. Okay, so we have our holes in. What I'm going to do at this point now is I'm going to save this model, because we can use this part again to make the second half of the hinge. So I'm going to save this. So now we have we have two parts that are both at the same stage. So this is the basic hinge shape. We haven't done any shaping on the actual hinge itself. Okay, so we're going to start drawing the gaps for the fingers here. Sorry about the cut. I forgot to switch back to my hinge 1 part instead of my hinge 2 part. So then the first thing we need to do is we need to put in a reference plane. This is just so that you can draw on this particular plane. You have to draw on a plane, you can't just draw in midair. So we're going to draw this in 10mm from the end, and we're going to open a sketch up on this plane. And I'm just going to come normal to this plane just so we can see better what's going on. So I'm going to draw a circle, and this circle is going to be concentric to the circle that we drew originally. And this circle is going to be 8.8mm wide. So just to explain where the 8.8mm comes from, this circle is 8mm wide in diameter, because its radius is 4mm from the height. So I discovered through different experimentation that the best gap to leave for print in place parts is 0.4mm everywhere that you want an air gap. So you need 0.4mm on each side. So that's where you get the 0.8mm extra from. So what we're going to do now is we're just going to extrude cut this through some of the part. And we're going to extrude this 10mm into the part. Now we're going to create a linear pattern of this, just so I don't have to draw it again. So we just need to pick any edge that's going in the direction that we want, and then the feature that I want to pattern, which is the cut. And I want it to be 20mm, and I only need one of them. Sorry, 2 of them. So that's going to create another cut here. So now we have our two gaps. So we've created 3 fingers on this hinge. So we're just going to put in some more fillets. Again, 2mm, just because that's what we've been using. And they're going to go in here to create a rounded edge and get rid of these sharp edges that are there. So that looks a bit better now. So we're going to draw the actual kind of lugs that come out into the other part on this piece. Just because I think it's better to draw them on this piece than draw them on the other piece. But the first thing I'm going to do is I'm going to hide this plane. I like to hide my planes and axes that I use for referencing, just because it makes the part easier to look at and follow. Okay, so I'm going to open a sketch on the top surface of this model. And we're going to start drawing the sketches to do the revolves of the lugs in between the gaps. The reason we can open the sketch on the top surface of this model instead of having to open a new reference plane is because this surface is 4mm up off the top plane, and this top of this is 8mm above the top plane. So this surface is actually in the middle of this surface. So that just makes it easier for us when we don't have to draw another reference plane. So I'm just going to look onto this, and I'm going to start drawing my sketches. So the first thing I'm going to do is I'm going to draw a center line, and I'm going to make sure that this is 4mm away from the edge of this, because the center point of this line is no longer in the center of this circle that we originally drawn because of the fillets that we've done. So I just wanted to make sure that that is actually in the middle. The next thing I'm going to do is I'm going to start drawing half of the lug. So I'm just going to get the basic shape of the lug here. And remember, we have to close off our sketches when we do revolves. So the height of this is going to be 3.8 mil. We'll go through these measurements in a minute. The base of this is going to be 2 mil. And the top of this is going to be 1 mil. So where I got 3.8 mil was I originally wanted to have it, when I originally drew this model, I drew it for a 0.2 gap between everything. But that wasn't enough because the parts fused together. So I redesigned it to be 0.4. So originally this was 4 mil and there was an extra 0.2 mil of a gap. But I had to pull this back to 3.8 mil because when I put this out to 4 mil and then put another 0.4 mil on top of it, there actually wasn't enough plastic in the middle for the other piece to hold together. So that's why it's kind of an odd measurement at 3.8 mil. So the next thing I'm going to do is I'm going to mirror this onto the opposite side of this piece. So I just need to find a center point here. Yeah. And just go to the center point of that line. And we will mirror this across the other side. It'll just save us having to redraw this on the other side. Also, if we want to come back and change measurements, if we change this one, it'll change all of them. So that's kind of a handy thing to do when you're designing things anyway. Draw as few things as possible so you can put in as few measurements as possible, while keeping it fully defined as well, obviously. Don't just use as few measurements as possible. We also want to put in a center line here so that we can mirror it onto the other side. Again, I want to keep all of this fully defined, so I'll just put in another dimension. This dimension does not matter at all because of the length. This is not important. I just want to get the mirror right. So we want to mirror this, all of this, into the other side, into the other gap. Mirror this about this, and that's going to draw that over there. So now we have set up all of our lugs for our revolve. So we can come over here and do a revolve boss base. And the axis of rotation is any of these axes. Okay, so we've got our basic lug shape in here. You could do a bar the whole way through, but I'm not sure how well that would print with bridging and stuff. So I just did these kind of cone shapes, or kind of truncated cone shapes. So the last thing we need to do on this part is put in some fillets. So I'm just going to put in some 1 mil fillets on the internal edges of these and on the ends of them. Just to round out the part and make it look a bit better. On the cosmetic parts kind of look better on this side. These are functional kind of fillets in here, just because you don't want any sharp edges on the inside of this, just to kind of reduce friction and stuff. So that should be the first hinge fully finished, and we can move on to the next part now. The last thing we want to do before we move on to the second hinge part is we need to slightly modify this first hinge and create another part using it. So in order to make the second hinge part, we need to have a version of this one with larger lugs so that we can cut this out of the other one in order to create the holes that the lugs will fit into. But we need the larger lugs so that there's a tolerance between both of the parts. So in order to do that, we just edit the sketch that the lugs are based on. I'm just going to come normal to that. And we're going to add a 0.4 mil tolerance to all of this. So 2.4, 4.2, not that one, and 1.4. And this will create the larger lugs that we need in order to do the cut. You may have some problems with some of the features that you did after this, like the fillet, so we'll just see what's wrong with this. Okay, the radius on this is a bit too wide, so we'll just change that down slightly. That's still not working. So we'll go with 0.8, and that should work, yeah. So that should be our finished part that we can use to cut out from the other part. So we'll move on to the second hinge part next. Okay, so I've opened up the hinge 2 part that we saved off the part that we were working on before, and we're going to start turning this into the second hinge part. So I need to create a plane that's 0.4 mil away from the edge of this piece. Again, a plane is just something that you can draw on. You can come normal to that and open a sketch. So it's going to be similar to the other one in that it's going to be a concentric circle to our other circles that we've drawn. They just need to be concentric. And this is again going to be 8.8 mil in diameter to give us our air gap. And we're going to extrude this through the piece. Extrude cut for 10.8 mil. Okay. And now I'm going to hide my reference plane. Okay. The next thing I need to do is I need to create a linear pattern. Any edge along the direction we're going will do. And it's going to be 19.8 mil apart and 3 mil, or 3 instances of this feature. So this is going to be this cut. I'm just going to finish that. Okay, so now we have our 2 fingers. So these fingers, the different measurements I used there were worked out so that there would be 0.4 mil of a gap between all of the fingers in both sides of the hinge. So the next thing I'm going to do is I'm just going to create some more fillets, just to get rid of these harsh edges. Yeah, so these edges on here are just going to be filleted. Okay, so that's a lot better. And now I need to fillet. Sorry, I forgot to fillet these edges. I'm just going to fillet them. Will I have this open? Sorry, this isn't a 2 mil fillet, this is a 1 mil fillet. Sorry, I mixed this up with a different command I had. And it's along the edges, not the faces. Sorry, it is the faces, yeah, it's still the faces, but it's just a 1 mil, not a 2 mil fillet. Again, to work out your fillets, you just mess around with the dimensions until it looks good and it's good. But these have to match the other fillets we've already done. That's where that 1 mil has come from. So the next thing I'm going to do is I'm going to insert our combined part that we had made previously. So insert part, and I'm going to pick this combined part that we have here. When you bring this into SolidWorks, make sure you tick the locate part remove copy feature. This will allow you to create mates after you've dropped in the part. And the 2 mates that we need to create are concentric circles. Any 2 concentric circles on this piece. And I'm just going to flip this around so that it's in the correct orientation. I'm going to add that. Don't click the tick yet because it'll get rid of that. And now we also need to bring these together. So that will have lined up those parts. And we can click the tick now. Now the next thing we need to do is we need to combine this part with the other part that we're trying to create. So if we go to insert features, combine, it's a subtract combine, and the main body we're using is this body here. And the body we want to combine is this one. You can see a preview of it there, so it is cutting out the thing. And we just and that's this part finished. So we now have our two hinge parts created. So the next thing we need to do is we need to put them together. Okay, so I've created a new assembly here in SolidWorks. When we print this file, we need to actually assemble it before we do that, because this is a print in place file model, and the part comes out finished and assembled after it's been printed. There's no further assembly done by the user. We need to put this together. So we're just going to insert our components here. Just put down the thumbtack so that we can insert multiple components all at once. So that's our first hinge part. And we're just going to bring in our second hinge part now. So that's our second hinge part there. And just close this. Now we need to do our mates. So the first mate we're going to do is between any of these circles. We want to create a concentric mate. And we're just going to flip this around so that it's in correct orientation, and that's that mate done. The next mate will be between any edge on the edge of this, just to line it up correctly. And that's all the mates that we need to do in this model. So you can see we have the gaps and the hinges fitting together properly. Now I just want to sanity check my design, so to check that the gaps are correct, I want to do a section view along the right plane. And I'm just going to bring this into the middle of the model to see the gaps at the center of the hinge. So we can see that there is the correct amount of space between all of those, and that should print correctly. We can drag it over and back just to see that there is a gap all along there. And there is. I might actually just check along the front plane as well, and just do a section this way just to make sure that you can see the gap there on both sides between them is correct, and it is. So this part should be ready to print. But by default, when you go to save an STL in SolidWorks, so if I just switch this to STL, it will save them all as separate STLs, all the different parts in the assembly. So you go into the options and you need to save all components of an assembly in a single file. And this will create one STL from your assembly. So we just need to save that. And this part is ready to be sliced now. So I'm just getting ready to slice the final model here. So I've brought my model into Cura inside Octoprint, which is the software I use to manage my 3D printer. So when you import the model, it'll probably be orientated incorrectly, so you just need to change the orientation of it. It doesn't really matter which way you print this, but I think that it might make a difference, so I'm just going to orientate it this way. This is the way I printed all my test prints and they came out fine, so I don't want to change that. I'm just going to position this on a place that's easy to get it off the bed, because the reason I put it over here is because this piece is kind of a large footprint relative to its height. It's kind of hard. It would be kind of hard to get off, so I put it near the edge of the bed, just so I can have kind of space. It's very close to the edge, so it's easy enough to get a knife under it. So I'm using an ANET A8. Just some basic settings. I'm using 200 degree nozzle temperature, 50 degree bed temperature. They're 0.2 layer heights. It's 20% fill density. That doesn't really make a difference because there's so little fill in this anyway because of the 1.2 2mm shell thickness that it doesn't really matter how much fill density you use. And I'm using a print speed of 30 millimeters per second. So this is ready to be sliced and then printed. Okay, so what I've got here is a time lapse of the printing. It takes about an hour and a half to fully print, so it's a quick enough print, and this is just the time lapse. Okay, so at the end of all that, we have our finished piece, and you can see the movement in it and the tolerances are good. On my ANET A8, for a print in place part, 0.4mm air gap between everything seems to be a good tolerance for working with print in place parts. You can see it moves quite well. Initially when you take it off the printer you might have to work it over and back a bit, but then after that it's fine. It moves very freely and it seems to be fairly good. That's it really. Thanks for watching this tutorial. I hope you got some value from it. If you're looking for the files, they'll be available on Thingiverse from the link in the description. Yeah, so thanks for making it through this tutorial and hope to see you again. Bye.